Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the working principle of accelerometer, which will be the continuation of the previous video. The working principle of accelerometer, how the accelerometer works and what the principle it incorporates. An accelerometer contains a small mass called a proof mass. Okay, a small mass which is also known as a proof mass, suspended by springs inside the device. Okay, suspended by the springs inside the device. The accelerometer contains a small mass which is also called as proof mass, which is suspended inside a spring, which is suspended by spring inside the device. In this diagram we can see that we have a mass over there, that is called a proof mass. A small mass contained is called proof mass, which is suspended with a spring in it. Okay, which is fixed with a spring in it. When the accelerometer moves or experiences a force, the mass resists the motion due to the inertia. When the accelerometer moves or experiences a force, the mass resists the motion due to the inertia. Okay, the displacement of mass is measured using capacitivity, piezoelectric, piezoresistive. We have three categories in the displacement of mass: capacitivity, piezoelectric, piezoresistive. In capacitivity, the change in distance between the plates. We have two plates here, right? Piezoelectric crystal and piezoelectric crystal. There will have a change in capacitivity. Will have a change in distance between the plates, the two plates. And in piezoelectric, voltage generated by a pressure. In piezoelectric, the voltage which is this, that is generated by the pressure which is given to the spring suspended with the mass. Okay. In piezoresistive, change in resistance, change in the resistance of the spring. Okay. This displacement is then converted into an electrical signal which corresponds to the amount of acceleration, where this displacement is converted into the electrical signal which corresponds to the amount of acceleration, where we have three categories: capacitivity, piezoelectric and a piezoresistive. These are the three different types of accelerometers which is incorporated in all the applications. Okay. Next, advantages of accelerometer. What are the advantages? As I told you already, in this diagram we can see that it can rotate in three axes: x axis, y axis and a z axis. Z axis is called yaw, okay, and x axis is called roll and y axis is called pitch. Okay, x axis is roll, y axis is pitch, z axis is called yaw. Okay, the advantages of accelerometer is high sensitivity, compact in size. We'll have high sensitivity, we'll have compact in size, low power consumption. The power consumption of these accelerometer will be of very low. We'll have real-time monitoring, multi-axis measurement. As we have x, y and z axis here, it will be accessing in the multiple axis rotation. Reliable and durable, cost effective. Okay, high sensitivity, compact size, power, low power consumption, real-time monitoring, multiple axis measurement, reliability, durability and cost effective. The disadvantages of, what are the disadvantages of accelerometer? Susceptible to noise. Since we are using the accelerometers, we have different three categories of accelerometers, the noise can be measured. Okay. Limited range. Okay, this accelerometer can be used only for a particular range. Temperature sensitivity can be measured. Requires calibration. Since we are using different types of materials in the accelerometer, we need calibration regularly. So this is will be a main advantage of this accelerometer. Cannot measure rotation. Okay, this can rotate in three different axes, but the entire rotation cannot be identified in the accelerometer. This is the main disadvantage of the accelerometer. Susceptible to noise, we have noise issues. Limited range, will have only to a limited range of to limited range to be measured. Temperature sensitivity, will have a temperature sensitivity also. Requires calibration. Since we are using different types of materials, the calibration of accelerometer is required all times. And next one is cannot measure rotation. Since we are having three different axes also, x, y and z axis, it cannot be rotated in the it cannot be measured in the rotation axis. Okay. Applications where we can use the accelerometers are fall detection. Once a product is placed and it is going to be fell down, that can be detected by using the acceleration process, which is mainly used in the robotics. Okay. Active monitoring of a patient or something else can be done. Heart rate monitoring can be done. Prosthetic controls, sleep monitoring, patient posture detection, how the elderly patients can be in a bedded patient, so that their position can be monitored. Swallowing and tumor analysis where we have some injuries in your brain, that can be analyzed using the accelerometer component, which is present inside the biomedical equipments. Okay. Fall detection, active monitoring, heart rate monitoring, prosthetic controls, sleep monitoring, patient posture detection, swallowing and tumor analysis. These are the applications of accelerometer. Thank you.